Toolbox talk, guys. Today we deal with a hot topic, temperature. What's one of the most common issues you have?
A fan leave the work. We're going to call it that. That tends to brings up your temperature or a fuse blow.
We would check coolant level. We would just open the radiator cap and see that it has coolant, and we say, right, it's good. But we don't change coolant. And not just changing coolant, but servicing the coolant system altogether. If you can't keep your engine cool, that means it's going to run hot. If it's going to run hot, that means it's going to lose its efficiency, and it's going to have increased wear and tear on the engine. So one of the things that people fail to do is replace the coolant and the thermostat on time. Most modern cars now come with a thermostat to help bring the engine up to an operating temperature as quickly as possible and maintain that operating temperature. We have a culture in Trinidad and Tobago that anytime the car starts to overheat, we take out the thermostat and pelt it in the bush, and then we just full back coolant or water and we go again. Now, people might say, but the car working good. That ain't affecting anything. When the car takes longer to heat up, that means it remains in something called open loop for a longer period of time. That basically means that the engine, the computer sends fuel to the engine, a little bit more fuel to the engine, to help it get to operating temperature a little bit faster. From time to time, whenever you're going to do a coolant system flush, it's generally every 2 years. My advice also is to take your radiator out and pressure wash it in reverse from the back, because you're driving going forward all the time. You have a lot of dust and grime and bird feather and all kind of thing going, and bugs going to stick in the front of the radiator.
And this is our next tip too for car owners. You know, we like going to the beach and stuff, right? When you go to the beach, instead of parking with your radiator facing the sea blast, always try and turn the vehicle in a direction where it doesn't get that direct salt content going through your radiator, because that breaks up the aluminum after
oxidation,
time. Yes.
And of course, we use our Radol
Ultra Radal Premium Long Life. We have designed it pre-mixed already, not with tap water, but all with deionized water to give you that perfect cooling.
Tap water is a habit of Trinis. They use tap water in your radiator. Whether it be a brass type radiator or aluminum radiator, it's not the best thing for your radiator. Never so often you'll suck in a bird or a few feathers or some dust or some dirt or some oily residue. You may have stripped a fan belt or so, and it would have got thrown into the radiator. It's important that you remove these little bits.
Or something, a whole plastic bag.
A plastic bag, yeah, it happens.
And then you wonder, how my temperature going up?
I found a dead rat in a radiator before. Alright guys, that brings us to the end of another episode of Toolbox Talks. Join us another time as we delve into motoring and maintenance of your vehicles.
Good afternoon and welcome to Ultra Lubricants Protecting What Counts webinar series. My name is Michelle Salandi and I will be your host for this afternoon. It gives me tremendous pleasure to welcome all of you who are viewing here on Zoom, as well as those tuning in on our YouTube channel. Welcome to the fourth in the series of webinars for the Ultra Lubricants brand. Let me give you a bit of background. Ultra Lubricants has partnered with the National Energy Skills Center and the School of Continuing Education to bring these webinars to you. On this, our fourth webinar, we are grateful for the feedback we have been receiving and that we're able to reach our target audience. We are happy to have the mechanics, spare part outlets, as well as NESC automotive students with us. Thank you again for joining us. Today's webinar is entitled Keeping It Cool and will address cooling systems, operation, and maintenance. But before we get to that, let me talk about our partner, the School of Continuing Education Department. The School of Continuing Education Department is responsible for initiating, creating, developing, and implementing growth opportunities amongst multiple organizations with the intent of reaching new markets and forming new partnerships with other agencies and/or organizations. So naturally, they were very enthusiastic when approached by NP to host these webinar series. As you already know, and this has been mentioned in previous sessions, Ultra Lubricants is the premier lubricant brand of NP, offering a range of internationally accredited motor oils for all classes of diesel and gasoline engines, as well as host automotive products. And we also take pride in blending world-class lubricants for a unique climate here in the tropics. Ultra has been in the business for 40 years. As a matter of fact, we celebrate our 40th anniversary this year. And over the years, we have developed a reputation for blending original equipment manufacturer OEM approved and American Petroleum Institute API certified quality lubricants, including our own Ultra Lubricants. And this has resulted in opportunities for us to blend for other multinational brands, thus putting Ultra Lubricants on par with the quality of other international lubricant brands. Just a bit of additional information. Ultra is an experienced blender of OEM original manufacturer approved lubricants. We manufacture American Petroleum Institute API certified lubricants, as well as we have a long history of blending for international brands. For the multinationals who may be tuning in, we would be happy to blend on your behalf. So having shared all this information on Ultra, coming up next, we have a behind-the-scenes look at how our lubricants are made. We invite you to take a look at this very interesting video, and you will see why we stand by the quality of our products. Take a look.
In the Caribbean, we move to the rhythm of the islands, its people, flavors, and cultures. At National Petroleum, we focus on this movement as the energy that guides us and as a leader in the research, development, and manufacturing of the only brand blended specifically for our tropical conditions. We take pride in facilitating this movement day to day, town to town, and nation to nation. As a team from our talented engineers, transport partners, NP has embodied these values into our Ultra Lubricants line. Designed for frequent stopping and overall engine efficiency, the Ultra brand represents the next generation in lubricant technology, including 100% fully synthetic oils, with innovation and products that perform under the exacting specifications of today's modern vehicle. NP Ultra Lubricants that has been trusted throughout the region for decades. In that time, you may have come to know the brand, but do you know how we make it? The process begins with the delivery of high-quality base oils and additive packages shipped by tanker to the plant, purchased from leading with proven track records for superior quality. These raw materials are pumped into holding tanks for use in each new batch to be blended. The work of identifying the exact blend needed to obtain the required specifications certified technicians at the on-site lab. Exacting specifications are met for each new batch produced, and orders are then sent to the blending station. Here, the work of skillfully bringing all components lubricant begins. With a blending capacity of over 20 million liters per annum and an impressive 249 stock-keeping units produced, the blending operations of the plant manufactures over 50 different lubricants across a number of classifications. Over the years, NP's excellent reputation for blending OEM approved and API certified quality lubricants, including its own Ultra Lubricants, has resulted in opportunities to blend for other multinational brands, thus putting Ultra Lubricants on par with and even exceeding the quality of other international lubricant brands. The filling lines are where various sizes of bottles, pails, and even drums are filled in a fully automated process. With an average of up to 1,200 4 and 5 liter bottles and up to 600 pails filled each hour, this cutting-edge filling plant offers world-class performance, efficiency, and accuracy. Additionally, specially ordered 55 American gallon drums of lubricants are filled on a dedicated line and produced on site. The freshly blended lubricants are pumped overhead to the designated line to match the orders being filled. On this line, the pails first get their labels, then along to the filling station, where they are filled using state-of-the-art mass flow meters at a rate of up to 600 pails per hour. With the lubricant sector growing exponentially, this top-of-the-line filling station makes it possible for NP's Ultra Lubricant lines to meet the demands of the local, and at the other lines, bottles are swiftly led from labeling to filling, all within a fully automated process. This carousel individually seals up to 1,200 bottles per hour. Each bottle and pail are imprinted with a quality control traceable number and displays the date and time the product in each bottle was filled, giving an accurate record that meets international quality assurance requirements. A final inspection, and then it's off to the individual packing machines. This highly efficient and very impressive process completes the packing stage within a caged area designated for the safe and efficient operation of a high-tech robotic arm. With its anti-collision functions enabling very rapid movements, this robot is able to lift up to 150 kilograms of stock at a time. With great precision, the robot keeps the packing process up to speed, just as the NP brand keeps a pace of new and emerging markets, customer needs, and technological advancements across the nation and across the region. Ultra Lubricants, world-class lubricants for tropical conditions.
And there you have it, a glimpse of how we make our lubricants right here at NP Sealot's Port of Spain compound. But do you know when you can get these products? Our Ultra Lubricants brand is available at multiple spare part outlets across Trinidad and Tobago. 700 plus spare parts outlets sell our quality lubricants. In addition, you can visit our 38 plus quick shops across the country and you will find Ultra Lubricants there. For those who are viewing by Zoom, if you look in the chat, you will see that we have posted the names of our Ultra Lubricants sales representatives who are willing to assist with orders, and if you are looking for particular products, they are here to serve. They are Stephen Subaya and Sulin Harilal. Moving on to our next item. We have shown you how we make our products, so now we will take this opportunity to dispel any misconception about the Ultra Lubricants brand, or what we call fake news. Over the years, we have heard 4 pieces of fake news for which we want to set the record straight. So let's deal with the first one. Ultra lubricants are blended with used oils or substandard base oils. That is absolutely incorrect. The facts are that OEM and API approved ultra lubricants are blended with base oils and additive packages from leading international suppliers who have proven track records for superior quality. Let's move on to the next one. If your vehicle is serviced by a car dealership, using Ultra Lubricants will void your warranty. Now, I know how people are about warranty and their new vehicles, but the facts are that any brand of engine oil that meets the specifications as stated in the owner's manual can be utilized without voiding the warranty. So ask for Ultra by name and know that your car is covered on and off the road. On to another bit of fake news, which says that Ultra Lubricants are inferior to popular international brands. Absolutely false. High-quality base oils and additive packages purchased from reputable suppliers are used to blend OEM and API-approved Ultra Lubricants, putting Ultra on par with the quality of other international brands. The final one is that Ultra does not have a synthetic line of engine oils. This is absolutely incorrect because Ultra produces high-performance, fully synthetic engine oils designed for diesel and gasoline engines and specifically blended to meet the demands of tropical conditions. And there you have it, fake news dispelled and put to rest. And we've shared the truth with you as it relates to Ultra Lubricants. Thank you for staying with us. We certainly hope that these webinars are beneficial. To our mechanics who join us every month, we are happy to have you. This particular webinar is on cooling systems, operation and maintenance. As mentioned, the theme is keeping it cool. To take us through a presentation on the functions of a coolant, we now invite Mr. Dwayne Bryan, our technical associate. Over to you, Dwayne.
Thank you very much, Michelle, and welcome all. All right, so let me share my screen now. Right, so this afternoon, as we are looking at coolants, we're going to take a look at the functions of a coolant. All right, so firstly, as we saw the video of the overview of NP's blending operation, let's just give you a background into NP's operation. So we are first-class manufacturing operation with robust distribution channels throughout Trinidad and Tobago and the Caribbean region. We do contract blends for world-class brands, and our blending capacity is over 20 million per annum, which means that we can blend for Trinidad and Tobago as well as the entire Caribbean. We have over 50 different lubricants manufactured at National Petroleum under the different categories such as engine oils, greases, transmission fluids, gear oils, coolants, industrial oils such as turbine and hydraulic oils, as well as synthetic compressor fluids. At our facility in Silats, we have an ISO 9001 certified laboratory linked to the Institute of Petroleum, and all of the equipment are calibrated by the Trinidad and Tobago Bureau of Standards. We also have a technical support team that is highly trained, and we provide after-sales services such as oil analysis, lubrication consultancy, seminars such as this, as well as waste oil disposal for anyone utilizing the Ultra Lubricant brand. So the functions of a coolant. So as you can see, engines produce more work to convert into useful heat. Right? You can see the diagram shows the different parts of the cooling system. And the cooling system main function is to manage the temperature by removing, circulating, and dissipating and controlling the heat produced by the engine. The cooling system controls these temperatures of all the metallic and non-metallic material temperatures and protects the temperature of the other engine fluids. So the coolant not only protects the engine, but the engine oil and the different transmission fluid, different fluids that produce heat as well. More than 40% of engine problems originate in the coolant system. Right? Coolants are classified based on their performance and the type. The performance means such as industry specifications or OEM specifications, and we'll get into those different specifications in a while. The type of coolant, right, is generic terms used to group coolants based on their additive chemistry. So some coolants may have what we call rust and corrosion inhibitors, whereas others may not. Some are just supplemental maybe just supplemental coolants, and whereas others may be different types of other coolants as well. So in terms of performance specifications, this lists the different specifications for coolants. As we can see, the major specifications include ASTM standards as well as OEM, original equipment manufacturer coolant standards. So ASTM D3306 is for light duty requirements. ASTM 6210 is for heavy duty, such as the diesel engines, right? And we have various OEM and CS, which is the common standard 1403, which means for the heavy duty different standards, as well as generators as well. There are three main types of coolants that are utilized in automobiles. The most commonly used is an ethylene glycol coolant, which the Ultra Radar is based on. We are seeing a lot of new coolants that are being based on propylene glycol, mainly because the ethylene glycol does have a detriment to skin. Propylene glycol is more environmental friendly coolant, and we are seeing this coming up on the market. Very small amount of usage for the glycerin type coolant. So the main function of the coolant really is to lower the freezing point, especially in those temperate countries, but also it has that's what we call antifreeze. So you'll hear people saying antifreeze, but it also has what we call an anti-boil protection as well, which is what we utilize it in the tropical and Caribbean region for. So the coolant raises the boiling point to 100 degrees Celsius for ethylene glycols utilizing it at a 50% with water. And when you use the radiator cap, it goes to about 129 degrees Celsius. Right, so therefore it reduces the film boiling. Three main types of coolant utilized today are conventional coolants that are just the ethylene glycol alone. Right, they have the shortest service interval and requires most maintenance. They are changed probably every 2 years. We have the hybrid coolant, which is the conventional plus the organic additive technology coolant. And then we have the OAT coolant, the organic additive technology coolant, OAT coolant, which gives you, it's more of a long life coolant, so it gives you the longest service interval. It's more robust to contamination, and it's preferred by most OEMs. So most OEMs, when you see a showroom vehicle, it comes with an OAT coolant. Here gives you the different aspects of the different types of coolant in terms of technology, how long it can go, the maintenance, and some of the different maintenance highlights. So what can go wrong with your coolant in your system? Well, one of the major failure modes that can lead to costly rebuild is what we call liner pitting. So coolants that are not properly formulated or does not have this the additives to protect against this can lead to liner pitting, which can lead to changing the radiator coolant. Sometimes the additives drop out in the coolant, mainly again due to poor formulation, contamination of dust and dirt, and adding other things to the coolant. Right? Very important to check your water source. As we saw from the video before as well, you must not use tap water. Tap water contains chlorine and other contaminants that can affect the coolant performance. Right? More water is not always better. Right? As we say, most coolants are 50-50 mix, and some coolants are also higher mix for higher applications. The OAT type coolants give more resistance to contamination, the organic acidic technology. Another thing that can go wrong is phase shield deposits. So it's very important to choose the proper coolant and properly maintain the system. Use a water filter to capture the contaminant in the system. Flux contamination can also occur. This is mainly seen where more and more aluminum components are being used for the cooling system. Aluminum heat exchangers often contain residual flux that can contaminate the cooling system. So it is very, very important to utilize a very good coolant, especially an OAT type coolant, for aluminum radiators. Right, so some of the key benefits for the premium long life, the Ultra Radar premium long life coolant. So as I mentioned, the Ultra Radar premium long life coolant, it's designed with the OAT technology. So it gives you the long-term corrosion protection for cooling systems. It has excellent seal compatibility with almost any type of cooling system, right? Maybe brass, aluminum, any type of sealing coolant. And it also has good storage stability. So it lasts much longer than the normal coolants and much longer than other hybrid coolants. The Radar Ultra Premium Long Life Coolant can go for 5 years, 350,000 kilometer service life, and it meets a wide variety of specifications. So it's not only used in gasoline engines, but it can also gasoline type engine, but also in diesel and also stationary generators. So you can see the different type of specifications, not just ASTM, but Caterpillar, Cummins, Detroit Diesel, and a wide range of different specifications. The ultra rather long life coolant can be used. We have it available in premix, so it's already 50-50 premix with deionized water. And we also have it available in concentrate in the 1 liter. All right, so we'll take your questions after. You can always post your questions on the chat, or after we'll take some questions after. Thank you very much.
Thank you, Dwayne, for that very informative presentation on the functions of coolants as well as the range of coolants in the Ultra Lubricants brand. But now we've come to the meat of the matter, which is, I know, what most of you will tune in for. That is the technical information. For this, I have the pleasure of introducing Instructor Kiran Singh Raghunan Singh to deliver a presentation on cooling systems. But before I do that, let me give you a bit of a background on Kiran Singh Raghunan Singh. Kiran Singh Raghunan Singh, has been an instructor at NESC for the past 20 years. He has 30 years experience in the automotive industry and has attained the Canadian Red Seal certification, Automotive and Heavy Equipment, Auto and Diesel, NEC. Welcome, Kiran Raghunan Singh, to address us.
Thank you, Ms. Salandi. So let me So good evening to all our participants and welcome to this session, which deals with the operation and maintenance of the cooling system. So first of all, we may ask ourselves an important question when we think about the cooling system. Why do we need a cooling system in our vehicle? Whether that vehicle is a car, a truck, an off-road machine, a stationary engine out in the industry. Why is it necessary that we must have a cooling system? Now, once we understand why we need a cooling system, then we could start to consider how important the cooling system is for the safe operation and for the longevity of the machine in question. So in order to be able to cover the reasons why we need a cooling system and how to keep this cooling system functioning properly, and what the various components of the cooling system consists of, we have outlined for this presentation a number of objectives. And these objectives will focus on important aspects of the cooling system so that we can get an insight, not extremely technical, but an insight that even persons who are not professionals in the field could understand and appreciate. So here are our objectives. First one, explain why a cooling system is needed by internal combustion engines. Secondly, identify the types of cooling systems used by internal combustion engines. Third, identify the components of a liquid-cooled engine. Fourth, describe the operation of a liquid cooling system. And finally, identify the maintenance needs of a liquid-cooled engine. So first of all, why do we need a cooling system for an internal combustion engine? And let's clear up one thing first, the internal combustion engines. So what is an internal combustion engine? An internal combustion engine is an engine which burns a fuel internally, and we normally describe this location as in the cylinder or the combustion chamber, to produce or release the energy from a fuel to drive the engine or drive the crankshaft of the engine, which itself is going to power or deliver power to some other parts that are connected to this engine's output. So an IC engine, internal combustion engine, has a thermal efficiency of approximately 36%. And when we talk about thermal efficiency, in brackets we have here, thermal efficiency is the ability of an engine to convert the heat energy of a fuel into usable heat energy to push the pistons in the engine, of course, to drive the crankshaft of the engine. 64% of the heat produced by burning that fuel is lost heat energy. 7% is lost to internal friction. 30% is lost in the exhaust system, and 27% is transferred to the cooling system. So when we burn fuel in the engine, it means all of that fuel is not used to drive the engine. And all of that fuel is not used to drive something that may be connected to that engine. Like in your car, you will have an automatic or manual transmission that is going to extract or utilize the power from the engine to drive the car through various other components. If you have a standby engine driving a generator, the engine must drive the generator. So we know that the engines, all of the engine's fuel that was burnt is not going to be available to drive the generator or whatever other components this engine is required to drive. A lot of that heat produced is lost. So the 27% that is transferred to the cooling system, this is the 27% that we are concerned with today. How we are going to deal with that heat that flows out of the engine components and to other components related to the engine. But first of all internal combustion engines are not the same. And this is understandable. We have different manufacturers. We have different designs of internal combustion engines. Engines are used in different locations, on cars, on trucks, in industry. They are used as standby engines. They are used to drive various components. But basically, we could divide internal combustion engines as far as the cooling system is concerned into two types: air-cooled engines and liquid-cooled engines. So what is an air-cooled engine? So simply, an air-cooled engine is an engine that uses airflow over the engine to take away the excess heat that is transferred to parts related to the engine, or to put it simply, outside of the engine, so that heat could be dissipated into the air. So we have an illustration here, a picture in fact, of a simple air-cooled engine. This engine belongs to a lawnmower. And on this engine, at the top, you could see what looks like a fan. And further down in the body of the engine, we see little extensions on the engine components. This actually is the cylinder of the engine, and out here is the cylinder head. We see these extensions. Sometimes we call them fins on the engine. And what these normally do is increase the surface area on the cylinder head and on the cylinder itself. This fan here will generate an airflow. I have removed a shroud that fits over the top of the fan. And that shroud is designed in such a manner that air generated by this fan, which is going to be spinning once the engine is working, that air is going to blow downward over the cylinder fins and over the cylinder head fins. And as that air flows over those components, it will take away some of the heat that is generated by the combustion process. And in this way, air-cooled engines are cooled, or their temperatures are reduced in this way. So this is a small engine. In the past, we did have air-cooled engines used on cars and trucks. It is not common to see an air-cooled engine on a car or a truck presently, but these engines are widely used. Think about your lawnmower, your brush cutter, small generators, what we call standby generators, and a variety of small engines. Think about a motorcycle, for instance. So quite a lot of equipment that is common to us today use air-cooled engines. So there's no liquid cooling system associated with these engines. They are cooled simply by air flowing over specific components of the engine to remove excess heat. And then here we have a picture of another engine. This one is in a car. And immediately we see things that would suggest to us that this engine is a liquid cooled engine, because first of all, to the front of the vehicle, we see the top of what will be a radiator. And sometimes a radiator is referred to as a heat exchanger. It is in fact a heat exchanger. We see hoses that could transfer water from the engine to the radiator. There would be another hose that will transfer water from the radiator to the engine. So there's a complete circuit for water to flow through. On the right, we see a radiator cap. This allows you access to the radiator so that you could check the water level inside the radiator. You could examine the condition of the coolant. If you have special testing equipment, you'll even be able to test the specific gravity of the coolant. Next to the radiator cap and the radiator, you see what looks like a container with a hose going from a little area below the radiator cap into this container. This container is referred to as an overflow container or an expansion tank. And this is quite common in machines or engines that use liquid cooling systems. While we are on this picture, we can also see drive belts. Here we see a drive belt that will drive a pulley. We see that belt continuing all the way down to the lower part of the engine, which we don't see quite clearly. But there's what is called a water pump further down, and that belt is going to drive the water pump. So it means there are components that is going to circulate the water in this cooling system, this liquid cooling system. So since there are many components associated with the cooling system, we want to look at and identify what those components are. So the first one we have, starting on the left side, we have a radiator, which is the heat exchanger, which is going to receive hot water from the engine. Airflow through the radiator is going to remove some of the heat from that water or coolant and return that coolant back to the engine at a lower temperature. This is why we call the radiator a heat exchanger. It is going to remove the heat from the water and give that heat up to the air. And there's one little physics fact we need to remember when we think about radiators and heat exchangers. Heat will flow from an area of higher heat to an area of lower heat. So if, for instance, you have a pot of water or you have a pot cooking some food on your stove, and by mistake, you touch that pot, you know the heat will flow quickly from the pot to your hand, and your hands will get burnt. That is one example of heat flowing from an area of higher heat to an area of lower heat. Same thing happens in the radiator. The water inside the radiator is going to be at a higher temperature than the air that is flowing around the radiator. So as this water flows through the radiator, the cooler air outside the radiator is going to have that heat transferred, and the heat is now going to be in the air. And to make the radiator even more efficient, you could have a fan, either electrically driven or mechanically driven by a belt. And that fan could blow air through the radiator and assist in dissipating that heat and improve the cooling efficiency of the radiator. Also, if the engine is mounted in a vehicle, movement of the vehicle as the vehicle drives along would cause an airflow through the radiator that would assist in dissipating this heat. So the radiator is an important component of the cooling system. Secondly, we have the radiator cap, and it is specifically identified as a radiator pressure cap because it holds a certain amount of pressure in the cooling system. By pressurizing the cooling system, meaning the pressure in the cooling system is not going to be zero, it is actually going to be close to 14 to 15 psi. By pressurizing the cooling system could operate at a higher temperature without the water boiling. So water normally boils at 100 degrees Celsius. If we pressurize the cooling system, the water could get up to 110, maybe even 115 degrees without boiling. And it depends also on the concentration of the coolant used in the cooling system. Under no condition should you remove that pressure cap when the engine is hot. You could get seriously burnt. You could suffer other damage other than being burnt. And the engine itself could suffer some damage if you remove that radiator cap when the system is under pressure. So all radiator caps will carry a warning label indicating to you, never open when hot. Always allow the system to cool down before you open that radiator cap. After the radiator pressure cap, we have the coolant expansion tank. So we know when things warm up, they expand. Same thing with the coolant in your engine. As the engine starts up from cold, the coolant is going to become hot. And that hot coolant must be allowed to escape because of its increased volume. And the increased volume of coolant has to be transferred to your expansion tank or the coolant expansion tank. And in the previous illustration where we saw the radiator cap, and a small hose leading from an area close to the radiator cap to the expansion tank, that transfer takes place as the expanding coolant lifts the pressure cap on the radiator and allows a small amount of coolant to escape into the expansion tank. Of course, as that coolant escapes, the pressure in the cooling system will be reduced a little bit so that the system could work at a specified pressure. And that specified pressure is determined by the radiator pressure cap. So the radiator pressure cap maintains a constant pressure in the cooling system so that every time the pressure exceeds that particular specified pressure, a small amount of coolant is going to escape into the expansion tank. Of course, there's also a valve in the radiator pressure cap that allows that coolant to return to the cooling system within the engine as the engine cools down. So there's what is called a vacuum valve in the radiator pressure cap that will allow coolant to leave the expansion tank and go back into the engine. So the engine is always filled with coolant once the system is functioning normally. Then we have the water pump. And of course, the water pump is there to circulate the coolant through the cooling system. We have the water pump drive belt. Most water pumps are driven by a belt from the crankshaft of the engine. So once the engine has started, the water pump is going to start to work and it will drive the coolant and circulate the coolant around the cooling system. We have water hoses. To connect the radiator to the engine, both inlet and outlet side, we use water hoses. And there may be other locations on the engine where other components are connected to the cooling system, and hoses are also used. In addition to hoses, engines may also use metal tubes to connect one component to another component within the cooling system. And we'll see some of that later on. We have cooling fans, either mechanically driven or electrically driven, to assist in dissipating heat from the radiator. Moving to the right-hand column, we have a thermostat. The cooling system has a thermostat that regulates the temperature of the coolant in the cooling system. So we'll talk about the thermostat a little bit later. Then we have the radiator bypass system. The radiator bypass system is a system that works in conjunction with the thermostat to control the temperature within the engine and in the cooling system. We have a coolant temperature sensor. Most engines now are computer controlled. And to determine the exact amount of fuel that an engine needs, the computer for the car needs certain information related to engine temperature. So for instance, when the engine is cold, the engine needs more fuel to operate and run smoothly. As the engine warms up, less fuel has to be supplied. So you have what you call a leaner air-fuel mixture ratio. The coolant temperature sensor is a critical component in terms of providing information to the engine computer on engine temperature. Then we have a temperature gauge and a coolant temperature sender. These two work together. So how does the driver of a car interface with the cooling system? Well, simply through the temperature gauge on the instrument panel. Where does that temperature gauge receive its signal? Well, that signal comes from, most times, the coolant temperature sender. So it's an electrical unit mounted on the engine in the cooling system that's similar to the coolant temperature sensor. It senses the temperature of the coolant in the engine. And it sends a signal to the gauge on the instrument panel. So the operator or driver of the car will know when the cooling system is at normal operating temperature, if the cooling system is above normal operating temperature, and if the system is at risk of being damaged. So that is an important operating system for the cooling part of the engine. It is important that the engine operates within a safe operating temperature range. Then we have a heater core. Many cars, many vehicles will have what is called a heater core, which is another heat exchanger similar to the radiator but smaller, mounted under the dash. And it is part of what we might call the HVAC system, which we'll go into a little bit later, which is the heating, ventilation, and air conditioning system. So especially in colder countries, if you have snow outside, you want to know that inside the car is nice and warm for the driver and passengers. So coolant from the engine or the engine's coolant system could be transferred through this heat exchanger under the dashboard and supply heat to warm the inside of the car if it is too cold. Even in situations like ours where the place is warmer, you will know that sometimes, especially at night, your air condition could simply become too cold even at its lowest speed. And what you do at that time is you adjust the thermostat for your AC system, and the AC wouldn't be as cold as before when you adjust the thermostat. What you literally do is allow some hot water from the coolant system to flow through that heater core under the dashboard, and that is transferred by air that is flowing over that heater core into the cabin of the vehicle to warm the inside of the vehicle. So we'll even see a little more of that as we continue. So here we see the instrument panel of an engine, and we could see the temperature gauge. Some vehicles actually don't have a temperature gauge. They may have a light. A blue light when the engine is cold, a red light if the engine is overheated, and when the engine is at normal temperature, no light is showing at all. So some of those things that we spoke of just now, we just want to take a quick look at them. This is another photograph of an engine. So we could see a radiator cap. We could see a hose coming out just under the radiator cap. And that hose leads into this container here, which is the expansion tank. We see a water hose going into the engine, and we see the upper part of the radiator here. And looking on the inside part of the radiator, between the engine and the radiator, we see some electrical connection, and inside these two housings are fans, electrical fans that will turn on and assist in dissipating heat out of this radiator to keep the engine at normal operating temperature. Here we see a mechanically driven fan. This fan is driven directly from a belt connected to the engine's crankshaft. We also see two water hoses here that will transfer water, not necessarily from the radiator, but on other parts of the engine, and to provide a water supply to other components on the engine that may need warm water. Here we see an assortment of components, parts that are going to be found in the coolant system. Here is a photograph of a water pump. To the front of the water pump, we see a drive pulley. We see a belt. This is the belt that is going to drive this water pump from the crankshaft. We see here the thermostat. On the left side is the thermostat housing, one part of the thermostat housing. On the right side is another part of the thermostat housing. So these are how these components are laid out. This is how they are made, and this is how they look. The hoses used on cooling systems could be of different sizes. Sometimes they are of specific shapes. Of course, they are made to fit the different components of the cooling system. Here we see two parts of the cooling system on an engine. On the left side, we see an electrical wire, looks like one single wire, connecting to this unit. This is your temperature sender unit that is going to send the signal to operate your temperature gauge. On the right side, we see another connector. This one connects to the coolant temperature sensor, and this provides the signal that will tell the computer on the car what is the temperature of the coolant water or the coolant in the engine. So we see that the coolant system also consists of electrical components. Our next objective, describe the operation of a liquid coolant system. How does the coolant system work? So the operation of the coolant system, first of all, with the thermostat closed. With the engine in operation, the water pump will circulate the coolant through the water passages. These water passages in the engine is sometimes referred to as water jackets. Within the engine and back to the intake side of the water pump. So you notice when the thermostat is closed, the water is circulated within the engine. Water may also be supplied to a heater core inside the vehicle, and the heater core itself, even though it is in the circuit, it doesn't necessarily have to have water circulating through it, because there would be a separate valve that operates water flow through the heater core. You don't always want the heater core to be functional, or you don't always want the heater for the inside of the cabin space in the car to be warm. So you could turn that water supply on or off. The air that is generated and flows through the heater core, when the heater core is functional, meaning water is flowing through it, hot water, that air is mixed with cool air generated by the AC system, and we refer to that as blended air, to supply air into the cabin of the vehicle at a temperature that is going to be comfortable for the occupants of the vehicle. The final point, the regulation of coolant flow through the heater core is determined by the HVAC thermostat setting. HVAC simply means heating, ventilation, and AC. Normally, we are accustomed to the AC, which is the part that cools the car, because we live in a hot country. But persons who live in colder places, they also need heating inside the car. We also need heating inside the car, especially at night, when the temperature might become too low and uncomfortable inside the car. So you simply adjust the thermostat for the cooling system, and you will realize that the air that is coming through the air vents now are coming through at a more comfortable temperature, at a little bit higher. So operation of the cooling system with the thermostat open, and the thermostat will open as the engine warms up. Normally the engine must get to about 63 degrees before the thermostat starts to operate, 63 degrees Celsius. And by about 80 or 83 degrees, the thermostat should be fully open. So there are times when the thermostat will be partially open, allowing partial flow of water out into the radiator. And after that, as the engine warms up and gets to its operating temperature, normal operating temperature, the thermostat is going to be fully open. So with the engine in operation, the water pump will circulate the coolant through the water passages or water jacket within the engine and out to the intake side of the radiator. So now water is flowing to the radiator. Secondly, coolant will flow through the core of the radiator to the outlet and return to the inlet side of the water pump. So coolant will flow through the radiator. Air flowing through the core of the radiator is going to take the heat away, and the water is going to return to the engine at the inlet part of the water pump at a lower temperature. It has given up the excess heat from the water. Airflow at a temperature lower than the coolant will flow over and through the core of the radiator, removing the heat. The HVAC system operation remains the same. Our next objective, identify the maintenance needs of a liquid-cooled engine. Liquid-cooled engine. First one, inspection of coolant level and condition. This is the sort of thing the owner or operator of a vehicle will do on a regular basis. You inspect the coolant level. You want to make sure you're not running with low coolant. Inspection of the radiator cap. You want to make sure the components of the radiator cap are in good condition. Inspection of drive belts. You have a drive belt to drive the water pump. Inspection of water hoses. All the water hoses on the cooling system. Inspection of the radiator. You want to make sure you have no leaks, no signs of corrosion, no signs of damage. Replacement of the coolant thermostat at stipulated intervals as indicated by the manufacturer of the vehicle. And of course, replacement of the coolant also probably at that same time, depending on recommendations from the manufacturer of the vehicle. So here in this picture, we see a new part and we see an old part or a used part that is extremely deteriorated in condition. And this is what happens when you don't replace the coolant in an engine. Or if instead of using a coolant, you are simply using plain water. Plain water is going to oxidize and rust and deteriorate all the components within the cooling system in a short period of time. So it is important that coolant is replaced within the cooling system at stipulated intervals. Also, you want to be sure that sensors, for instance, this component here that is part of this housing, that is the coolant temperature sensor. This is the unit that sends the signal to the engine's computer to tell the computer what is the temperature in the cooling system. You could well imagine if this is the condition of that part on the engine, that sensor is also going to be coated with dirt and grime, and it is not going to be sharing or sending the correct signal in terms of water temperature or coolant temperature within the engine. So this is a good illustration of what happens. Look even at the hose, what has happened to the hose. So it is important that coolant be replaced at the appropriate time. We know a lot about engines. We think about older cars having cooling systems and so on. We have to remember, even cars that are new generation, high-tech, like hybrid cars and electric cars, even those cars still have cooling systems. For instance, on a hybrid car, you will have a cooling system for the engine on the car, and you will also have a cooling system for the electronics that control electrical current flow to the drive motors. So those systems generate heat while you have conversion of electricity, because these cars work on three-phase current. So DC current has to be converted to three-phase in order for the drive motors to operate. The process of conversion generates heat, and that heat has to be dissipated. So what we are actually seeing here in this photograph is an expansion tank and a reservoir for the cooling system of this car, a hybrid car. And even if you have an electric car, because of the same level of electronics, inverters, converters, heat is going to be generated in electronic and electrical systems, and that heat has to be dissipated. The only difference with these systems, like in an electric car, for instance, because you don't have an engine to drive the water pump is going to be electrically driven. A motor is going to drive the water pump. But you will still need to replace the coolant at stipulated intervals. You will still need to inspect the cooling system in addition to inspecting everything else related to the engine. So thank you very much. I hope this presentation has been informative. If you have any questions, pretty soon we'll be taking the questions. Thank you kindly.
Thank you very much, Mr. Raghunanan Singh. I'm sure we all agree that his presentation was very informative and very instructive. So we've come to the part of the program where we take your questions. Every time we do these webinar series, we give the technical associate and the NESC instructor the opportunity to answer questions. So let's start. Kiran Singh and Dwayne, are you all ready?
Yes.
Okay, first question. Someone wants to know, there are so many car coolants out there, so finding the right product can be tricky. What are some points I should bear in mind when choosing a coolant for my vehicle?
Okay, well, first of all, I would like to turn that question over to Dwayne. But before doing so, I would just like to say this. It is important that you consult your service manual and specification for that particular car. Each new car comes with an owner manual that is going to indicate what are the specifications for the fluids that are used on this particular vehicle. So all cars do not use, or all engines do not use same coolant. So it is important to follow the specification. So I'll turn you over to Dwayne now so that Dwayne could, based on the specifications and the various coolants manufactured by NP, blended by NP, he is in a good position to answer that question clearly.
Thank you very much, Kiran Singh. Yes, so based on the specifications again, the vehicle will recommend what is the spec for the coolant necessary. Right, as we mentioned, there are three main types of coolant: the conventional coolant, the conventional ethylene glycol coolant, the hybrid coolant, which is a mixture of the conventional as well as the organic acid technology coolant, the OAT. So the coolant National Petroleum has is the OAT technology coolant, the organic acid coolant that gives you the longer life, right? It's an extended life coolant, right? Most manufacturers, as I mentioned in the presentation, most manufacturers recommend the OAT technology coolant, right? Most of the coolants that they come with are that. So whereas you'll see different colors, the colors does not really specify the, it does not really talk about the quality or the specification of the coolant. It really deals with the manufacturers are trying to identify this different type of coolant for the particular vehicle, right? So whereas you may see some are green, some are pink, yellow, red, as the case may be, as Mr. Kiran Singh indicated, check the specifications. Once it indicates an ethylene glycol coolant can be used, ultra radial premium long life can certainly be used in that vehicle. Yeah.
Dwayne, thanks for that. I think you would have answered a question because somebody asked, what do the colors of the coolant mean? And I believe you covered it in that answer. The next question, I believe, is for Kiran Singh. What is a coolant flush and when should I do one?
All right. Now, first of all, there's a question of whether we should use a flush for the coolant system, first of all. And when the person asking the question, I am not thinking about that flush being water. Maybe some sort of chemical that is going to be used in the coolant system to clean the coolant system. We have to remember something about coolant systems. Coolant systems consist of a number of different materials: plastics, aluminum, iron, rubber. All of these things are part and parcel of the coolant system. You may even have components like, for instance, the radiator. We could have aluminum, we could have brass, a combination of aluminum and plastic. So you have to be careful that the flush that is going to be used is compatible with all of these materials that the coolant system is made for. So first of all, if you need to clean your coolant system, you need to remove the thermostat from the coolant system, because the thermostat will be an obstruction to the free flow of water during the flushing process. You remove the thermostat, you put the housing back together, you will have to turn on the ignition switch, turn the thermostat to the hottest position so that the valve that closes the passage or or closes and opens the passage to the heater core under the dash for the HVAC system, that valve is going to be open. So while you flush the coolant system, preferably only with water first, you will get most of the contaminants and dirty water and remnants of rust and steel out of the coolant system just by using water under some pressure. If you have a flush that is compatible with the components of the coolant system, you can now put that flush into the coolant system following the recommendations of the manufacturer of the flush. Most times they would recommend that you run the engine for a short period of time, maybe 10 minutes, to circulate this flush through the coolant system. And then you would be required to drain the coolant system again, flush the coolant system with clean water to get all the flush out so that it doesn't remain in the system and deteriorate any parts of the system. Once you have done that, it means now you could refill the system with the correct concentration of your coolant, whichever coolant is specified for that particular vehicle.
Thank you for that. We have a next question. Someone wants to know, what are the reasons my car's coolant system may be leaking?
Okay, so the car's coolant system is leaking. So it means the customer is losing water from the coolant system. Now, as mentioned before, we have a number of components in the coolant system. And quite a lot of them could be responsible for a water leak. A water pump could leak. It could leak water or coolant out of the system. A radiator could leak water or coolant out of the system. Your water hoses could be leaking. You could have tubings, metal pipes, that carry coolant from one location to the next on the engine. Like in the example we saw, those coolant pipes could become rotted, especially if the coolant system is not properly maintained. And in such a situation, the pipe is going to become rotted and coolant is going to start to escape from the coolant system. Even the heater core that is inside the car under the dashboard, and this is critically important, even that could start to leak. And the water is not going to leak inside the car. The water is going to leak and drain through a passage outside the car. Now, in our conditions where the place is warm and hot, most of the time, most people, they don't ever use the heater on their vehicles. And what happens is the coolant that is trapped in the heater becomes stagnant and it becomes corrosive. And it starts to waste away the material that the heater core is made from. And the heater core may start to leak. So if you check all the components on the engine itself and you cannot find the source of the leak, it is quite possible that the leak is at the heater core under the dash. Now, to avoid problems like that, occasionally we should turn the heater on in our vehicles while the vehicle is in operation and allow water to flow through, or coolant from the engine to flow through the heater core, and that will flush the stagnant coolant out of the heater core and cause fresh coolant to flow through the heater core, and also flush the heater core and keep it functional. So as far as where the leak is, there's a lot of possibilities. One that people don't normally think about is the heater core under the dash. Hope that helps.
Thank you, Kiran Singh. Another person wants to know, why is my coolant light on and what should I do in this situation?
So I did mention some cars don't have a temperature gauge. Some cars actually have a blue light that is going to be on when the engine is cool. And as the engine warms up to normal temperature or operating temperature, the light is going to turn off. So you're not going to see any light. If the engine starts to overheat, the engine temperature is now going beyond specification, a red light will turn on the dash. Now, if you see that red light turn on, you are already in a situation either now start to overheat or seriously overheated. And that is extremely risky and dangerous for the engine. And of course, for the operator of the car also, depending on where you might be at that point in time. So if you see a coolant light on, and it indicates that this vehicle is overheating, what you should immediately do is pull aside, look for a safe place, of course, pull over to the side of the road, turn the car off, and let the engine cool out. So it would not do serious damage to the engine. Of course, you should not open the radiator cap and try to put water into the car. That is extremely dangerous. A lot of steam is going to be escaping out of the cap. There's the risk of getting seriously burned or scalded. So we want to make sure that you don't exacerbate the problems of the cooling system by you yourself becoming injured. Just let the car cool for a while. Give it a few minutes, maybe 10 minutes to cool off. And then you open the bonnet of the car and carefully look around on the engine and around the radiator and see if you can find the source of the overheating, because something may have caused the coolant to leak out, at least to a level that caused the vehicle to overheat. Now, there's another light that may come on some vehicles that would indicate a malfunction in something in the cooling system. So for instance, we talked about the expansion tank for the radiator that is closely associated with the radiator's operation. If the water level is low in the expansion tank, some cars do in fact have a sensor, a water level sensor or a coolant level sensor in that expansion tank to indicate that the water level or coolant level is low. So it may simply mean that the car is not overheating, but the water level is low and it needs to be attended to, because that could deteriorate to the point of low coolant in the cooling system, resulting in an engine overheat. So there are two lights that could possibly turn on. One for a low water level in your expansion tank, and the other one indicating that the car, with a red light, indicating that the car is actually overheated. Hope that helps.
Thank you, Kiran Singh. I have another question for you. I know you would have dealt with flush already, but someone wants to know, what is the best flush to use if your coolant system has developed rust?
Well, again, there's no best flush. First of all, rusting in a coolant system is an indication of poor maintenance of the coolant system. It means you did not have coolant in the coolant system, first of all, because rust is an indication of oxidation. Oxidation is a process that takes place between iron and water. The components of a coolant, in a coolant we'll have, of course, antifreeze. We also have rust inhibitors. We have antifoam agents. We have other components in the coolant, in the coolant that will prevent bearings and so on, moving components within the coolant system, like your thermostat, which has to open and close, so that those components could be lubricated and lubricated by components within the coolant. So first of all, if you have rust in the coolant system, it means either the coolant has been there too long or you just have water in the coolant system. So the first thing to do is flush the coolant system with water. That will get rid of most of the heavy material and rust in the coolant system. Secondly, again, because all coolant systems are not the same, you must select a flush. If you are determined to use a flush, you must select a flush that is compatible with all the components in your coolant system: plastics, aluminum, brass, iron, and anything else that might be a rubber, for instance, anything else that might be a constituent or part of the coolant system. you need to use a flush that is compatible, because all flushes are not compatible with all cooling systems. For instance, you could have a standby generator in an industry. The engine for that standby generator could be a massive diesel engine. Because it is a standby engine and it doesn't operate regularly, the coolant used in that engine could be different. The materials used in the cooling system could be totally different from what is used in your car. So it is extremely important to check your manufacturer's specification. And if you're going to buy the flush, you read the directions on the flush to make sure it is not going to deteriorate your cooling system any more than it is already deteriorated. Because you don't want to use a flush in your cooling system and then you see the radiator hoses start to burst, or they start to swell up, or your radiator develops a leak. You want to make sure that the flush that you're using is compatible with the materials and the components in your cooling system. Most manufacturers, in fact, would recommend you flush the cooling system with what is called normal water first, and then deionized water or distilled water. After which you will use coolant at the correct concentration in your engine. As Dwayne mentioned previously, the most common concentration is 50-50. 50% coolant, 50% deionized water. Yeah, so that is about the best recommendation I could make in terms of using flushes.
Just to add to that, Kieran Singh. So, because as he mentioned that you're using a coolant and it does not, rust is formed, which means that you're using a coolant that does not have the anti-rust protection or the corrosion inhibitors protection. So, wrong coolant in the first place. So, some coolants on the market does not have those properties. And that's why it's recommended to use a coolant that has the OAT technology or that has with the ethylene glycol and the additives in it. Right? So this is very, very important.
Thank you, Dwayne and Kieran Singh. Dwayne, this question is for you. Is it safe to say Radol is a water-based coolant?
Yes, most coolants for vehicles are water-based coolant. Once it's ethylene glycol, most oil-based coolant are mainly used in what we call metalworking fluids, or for CNC machine use, as the case may be. So Radol is a water-based coolant, ethylene glycol, and mixes with water, as the case may be. Yeah.
Thanks. We just have, I think, 2 more questions. This one is, how do I fix a coolant tank leak?
Okay, so most coolant tank, so for instance, we have radiators. I'm not sure if the question is based on the tank on the radiator, or if it is the tank like the expansion tank for the radiator or for the cooling system. If it is for the expansion tank, most cooling systems use plastic expansion tanks. Generally, expansion tanks, they will not bond well with sealants. If an expansion tank starts to leak, the best option is to replace it. Now, if it is a material that could be plastic welded, meaning that the material has not deteriorated to the point where it has become brittle and, showing signs of cracks and so on. Of course, if it has reached that stage, you should simply replace the tank, because it may just be wear and tear over the years that has now resulted in the tank leaking. So if the tank is relatively new, maybe it could be plastic welded. However, if the question is based on the tanks on a radiator, we have different types of radiators. We have radiators that have tanks that are made from brass. And if it is a material that could be soldered, generally these tanks are soldered on to the radiator core. So if the leak is one that could be fixed by soldering, well, then you could solder the tank. However, If it is a tank that is a plastic, so you have a plastic tank and aluminum core, it means you should replace the radiator. Now, we had talked about coolant systems being under pressure, meaning that when the engine is cold, the pressure in the coolant system is the same as atmospheric pressure. As the engine heats up, the pressure in the coolant system is going to increase. So even if you try to stick or patch a plastic tank on a radiator, when the pressure builds in the system, it is going to cause that wound on the tank to open and the leak will persist. Even if you plastic well a plastic tank on a radiator, it will not last too long. So the safer option is probably just to replace the radiator. So once you have plastic and aluminum combination as the radiator, replace the radiator. If it is one where the tank is brass is a material that could be easily soldered and repaired, and the core is a like material that could be soldered and repaired. It means soldering will fix the leak.
Thank you. Someone is asking, how do I top up my coolant?
Okay. So topping up coolant would suggest that the coolant is low. So first of all, of course, this will be done when the engine is cold. So it is safe to remove the radiator cap. So to top up the coolant, you will remove the radiator cap and make sure that you could see the level of coolant inside the radiator, all the way to the bottom of the radiator cap, or where the bottom of the radiator cap will be. And then when you look at the expansion tank, next close by to the radiator or connected to the radiator, you will see a minimum mark and a maximum mark. So it means when the engine is cold, the level of coolant in the expansion tank should be somewhere between the minimum and maximum levels. Now, the bigger question is what you're going to use to top up your radiator or your coolant with. And this will depend on the type of coolant that you have in your car. Because just to use an illustration here, let's say probably you have a green coolant in your car, but you have some red coolant in a container. I don't think it would be a good idea to use the red coolant to top up your green coolant. They might both be coolants, but they may consist of different materials. There may be different types of coolants with different additives and for different purposes. So first of all, if you have deionized water and it is a small amount that you really need to add, it may be okay to add some distilled water to top up the coolant. Other than that, you should use the same coolant, 50-50 mixture that was used to fill your radiator. That is exactly what you should be using to top up your coolant. You should not be mixing a different type of coolant, a different color coolant, a different specification coolant into the coolant system. In an emergency situation, I could well imagine you will simply put whatever water is available. And it is safer to put water in your coolant system than to mix the wrong type of coolant into the coolant system. So it does happen sometimes in an emergency situation, you need to do something because the coolant level is low. In such a situation, you will top up the coolant system with water, clean water, and subsequently, chances are you will have to do some repairs. You will flush the coolant system, do your repairs, and then refill the coolant system with the specified coolant. Right? So I would not recommend mixing coolants or just using regular water for topping up the coolant or the coolant level. But if there is a problem and you have a persistent loss of coolant, it means you have to fix the problem, flush the coolant system, and top up or refill the coolant system with the specified coolant.
Thank you, Kiran Singh and Dwayne, for capably answering all of our questions. And to all of you who are viewing on Zoom, thank you for still tuning in with us. Thanks for your attention and for your very interesting questions. Moving on, we're going to address the sessions that we have upcoming. But before we do that, we want to invite NESC to talk about their programs. We have Mr. Kevin Manik-Chand. He's the Senior Business Development Officer of NESC, and he's going to talk about not only their existing programs, but some of the programs that are coming up. Mr. Manik-Chand.
Thank you for your kind words of introduction, Mr. Landy. Right. At the NESC, right now we are busy with our recruitment drive for full-time programs in our diploma program, and we have the flyer there for a craftsman one-year program. Right. These programs are full-time in nature, and of course, automotive forms one of our strong courses that we offer. Also, in the craftsman, we have a one-year program in autotronics, which is mainly what we call auto-electrical, but has a lot of the electronics component built into the program. When in terms of the line of automotive, we also have a heavy equipment operator program that is driving. That program is about 4 months in nature, and we have a host of other programs that we offer at the craftsman level. Right now, we are still recruiting persons. The flyer is up there right now at our different campuses. I invite persons who want to apply. Time is short. We are seeking to start our next cohort as early as next week. So we just have a couple of days left. And I invite you to go to our website, nesa.edu.tt to register. There are a lot of persons that are applying because as we are recognizing in the industry, persons are turning to skills training for employment. We have a demand for our graduates in the industry. Constantly, on a daily basis, we have companies reaching out to us, looking for graduates to fill positions in Trinidad and Tobago. And with this in mind, we see with the demand for these skills, there should be a supply for students accessing these skills. Now, we also have our 2-year diploma program, which have a prerequisite of 3 CXC subjects. We are, of course, as I said, recruiting. The programs for the diploma are GATE approved, meaning that you have to apply for GATE funding to be able to access these programs because they are quite expensive because these are tertiary level education programs. And of course, we have our automotive services technician program. We have heavy equipment maintenance program as well. So we do both auto and diesel in a 2-year capacity. That is as it relates to our full-time program. Also, at the School of Continuing Education, we offer professional development courses. Over the past 3 years, we have offered fundamentals of hybrid courses that has been fairly well subscribed and oversubscribed. We are looking into the new financial year to offer these courses coming up again in October to December at our various campuses, including Tobago. We are also seeking to offer some new courses. Based on the feedback from these webinars, we have seen the need from you, the viewers, that there are need for some specialized automotive programs that we are seeking to build to give capacity of our automotive mechanics in advanced hybrid technology. So rest assured, we are working towards that. We will have your contact information to send you information so that you can be able to access these new courses that is coming up in 2020 for the rest of 2021 and 2022. And finally, I'd like to thank NP and the NESE family for coming and working together for this initiative as we try to impart knowledge to you, all the viewers, as we look forward to fixing our vehicles and our craftsmen out there, making us proud, not only locally, and we have some who have gone internationally as well. Thank you very much.
And we also at NP are happy to partner with you. So moving right along, just to recap, today we talked about keeping it cool, cooling systems, operation and maintenance. But if you are tuning into the next two sessions, and we hope that you will be, you can look forward to these topics. On Wednesday, 20th October 2021, we'll be looking at brakes, hydraulic system operation and maintenance. And on Wednesday, the 17th of November 2021, the theme is So Much Torque, where we will discuss drive shafts and CVT joints. To all our mechanics, spare parts outlets and NESE automotive students and others tuning in, we look forward to you joining us in the future. And now we come to our much anticipated item, which is a prize draw. As you may be aware, prizes are given at each webinar session, but the people who are rewarded are the ones who would have attended the previous session. Excuse me. So I want to share with you the names of 5 winners of the webinar 3, which was held last month. I will call out the names, and on screen you will see an image of the products that they will take home as prizes. The first name we have is Gabriella John, Jervin Patel, next name Kerwin Wellington, Larry Christopher. The final one is Michael Jacob. Congratulations to our winners. What usually happens is that after the names are called, the winners receive an email after the webinar session, and it explains to you the process you have to follow in order to redeem your prizes. So we say congratulations to all our winners in advance. We thank you winners for not only registering, but for tuning in to all of our episodes. We invite all of you who are tuning in to do the same to qualify to win prizes. So we've come to the end of the program, and there are a couple of people that we want to thank, those who are in front of the camera and those who work behind the scenes. A heartfelt thanks to Mr. Kevin Manik-Chand and the School of Continuing Education at the NESE. NESE instructor Kiran Raghunanan Singh, we say thank you. To the NP team, Dwayne Bryan and Melissa Thomas. To those working behind the scenes to make this webinar possible, Anchor Charles David and Stephen Subaya. And we also thank you, the viewers and participants on Zoom and those viewing on YouTube. We invite you to like and to share our Ultra Lubricants Facebook page. Thank you again for joining us, and see you next time on Ultra Lubricants, protecting what counts. Have a good evening.